Okay, so next up, we're looking at quartiles and which items. So similar to what we did with the median. Just as a quick reminder though, the quartiles are the things that split up into quarters. So you'll have the lower quartile and the upper quartile, which is at the quarter and the 3/4 position. So what I've written here is you need to be able to find the quartiles of both listed data and of group data, just like we did with the median. And so it's exactly the same rule as for the median. Well, for the median, we said this thing down here, didn't we? We did a half n, and we said if it was a decimal, then you round it up. And if it was a whole number, you use halfway between this item and the one after. It's going to be the exact same thing, apart from your lower quartile is the one where you'll do a quarter of n, and then your upper quartile is obviously going to be 3/4 of n. So for this list we've got here, it's the same ones that we do with the median. There's 5 here, and when I do 5 divided by 4, I'm going to get 1.25. So it's a decimal, so I'm going to round it up. So the lower quartile is going to be the second number. In this case, the lower quartile is 4. And when I do 3/4 of 5, well, 3/4 of 5 is going to be 3/4 of 5 is 3.75, so it's a decimal, and we're going to round it up. So it's going to be the 4th position for the upper quartile, and so it is 9. And you can kind of see how it's sort of spaced along equally as well. Now this one here, we've got 4 as n. So when we do a quarter of 4, we get 1. And if it's a whole number, then we use halfway between this and the one after. So a quarter of 4 is 1. So the lower quartile is going to be in between the first and the second. So you'll do 4 add 9 is 13, and half of 13 is 6.5 for the lower quartile. And when we do 3/4 of 4, we get 3. So that means it's going to be in between the third and the fourth. It's a whole number, so we go in between the third and fourth. So that's where the lower quartile would be. It would be in between 10 and 15, which is going to be 12.5. And just a quick note, if you imagine the median being in here, you can really see how they're kind of like equally spaced as we go along like this. Okay, let's do the next one. So we've got 7 here. So I'll do 7 divided by 4. 7 divided by 4 is obviously going to be a decimal. It's 1.75. So we round it up to the whole number, always rounding up for this. So we round it to the second for the lower quartile, which is 4. And we'll do 3/4 of that. So I'll just times it by 3. We get 5.25, and it says if it's a decimal, we round it up. So it's going to be the second and the sixth. 1, 2, 3, 4, 5. The 6th one here, so it's going to be 9. And then this last one, we've got 10 things here. So I'm going to do a quarter of 10. So I'm going to do 10 divided by 4. So it's 2.5, obviously, which means I'm going to round it up to find the third. So it's this one here. And then I'm going to do 3/4. So I'll multiply that by 3. Obviously, it's 7.5, and I'll round it up to the 8th. So the 8th one is going to be 10. So it's 3 and it is 10. Now, just to think, if you were going to find out where the median was, the median when you do 10 divided by 2 is 5. So it would be in between the 5th and the 6th. So it would be here. So you can kind of see that for this lower half of the data, the 3 is halfway from the bottom to the middle, and the 10 is halfway between the halfway and the end. So it really does make sense that we're putting this data out into those different positions. So just make sure you've memorized these and you know your rules about rounding up and going between halfway and the next and things like that. So let's try this now for grouped data. Well, this is just like with the median. So I've said here to find the lower quartile and the upper quartile of grouped data, you find a quarter of n and you find 3/4 of n, and then you use linear interpolation. I'm not going to do the linear interpolation here. I'm just going to find out the values that you need. So we better find out what these all add up to. I think we did these before. So 7 and 5 is 12, 13, 14, 15. I don't think I've done that right. 12, 13, 14, 15. Yeah, 16, 17. So there are 17 in total. And so the position for the lower quartile would just be a quarter multiplied by 17. And 17 divided by 4 is just 4.25. So I'm going to use the 4.25th position. And then the upper quartile is just going to be 3/4 of 17. So I'm just going to take this on my calculator, I'll multiply it by 3, and I get the 12.75th term. So I said I wasn't going to do linear interpolation, but if I did want to do linear interpolation on this one, well, it's the 4.25th, so we know it's actually going to be inside this first group that we've got here. I wonder if I can do it in my head. So I know I'm going to be going from 80 for the upper quartile, sorry, the lower quartile, sorry, and I'm going to be adding on 4.25 out of 7 multiplied by that class width of 10. What this would look like on the diagram is we're saying along the top the frequency goes between 0 and 7, and we want the 4.25th, and we're going from the 80 to 90 IQ, and here is the lower quartile. So it's 4.25 out of 7 multiplied by 10 for that class width that we've got there. So let's just quickly work that out. So that's 80 plus 4.25 out of 7 multiplied by 10. And so with the lower quartile is 86.07. So 86.07 for the IQ that we've got there. And you could do a similar thing for the linear interpolation of the upper quartile. Okay, what we're going to do next is looking at percentiles and deciles.